Hey folks, in this video we're going to start talking about how to implement ADTs. So the first thing I want to talk about is basically the common methods. So how do we implement those? Now this we already have some good background for, just having been through that 0.2D example from our earlier video. So what we want to really do, right, is we need to focus on these three things. Well, okay, I added a fourth one here just because, well, because it's important. But we need to focus kind of on these first three, as well as another one, which is typically not really implemented. By default anyways. So first thing, right, is talk about how we implement equals. We have, right, the example from the 0.2D, right, that's this block of code over here. Basically, right, we have this kind of a standard process. We need to first, right, check to see whether we're looking at something null, right? If we're being asked to check our equality, right, are we equal to something that is null, we have to immediately return false, right? Because there's no other way to query it. If we do something like .x on it or something like that, we'll throw a null pointer exception. So we have to always check that first, okay? So that's the first thing you will have. Next thing is you want to check to make sure you're looking at the right class. If something's coming from a different class than you, you can't possibly be equal to them. So that's the second thing we're always going to have to check. Third thing, we have to check our member variables. So basically, right, when you have an object, right, your objects are live in the system, right, they're no longer blueprints like classes, they're actually live in your system. They'll have, a bunch of different member variables in there, which together, right, are the state of the object. And so when we ask the question, are two objects equal, usually what we're asking is their state the same? And so what people typically write is they have this huge kind of, thing here where you want to check all of your instance variables. So here, x and y are instance variables. Now here, right, we're using them through the function, right, which is kind of a good practice, right, is to use them through the method you've implemented to access them, right, instead of using them directly. And we've gone through, right, and said basically, hey, x and y are the things in this class that exist, so I'll compare both of them. Now if I had something else like a z, right, I would need to add it here as well, right? So if I had a 3D point, right, I would suddenly get, z equals z. Basically, every single one of my member variables, right, my piece of data inside of my class, that thing needs to be compared, right? I want to know if these things are equal. If they're equal, right, so they should be equal, right, when it is the case that all of their state matches between the two different things that are being compared. Okay, I can't leave something out because then all of a sudden equals won't work. And you can maybe think about that and try to figure that out on your own. That's the way the world works. So yeah. That's our last process right there. Basically check all the member variables. Usually we do this thing here, right? So we do this, basically what they call it short circuiting and, because as soon as you get the first thing that disagrees, right, you're done, right? You don't need to evaluate all of them. The first thing that disagrees, you can go ahead and return false because it can't possibly be equal, right? If at least one of their member variables is different, then that means that the classes at a high level are not equal to one another. Moving down, we have toString. Now toString, you guys have already implemented. You basically just return a bunch of concatenated stuff, right? So that we won't really talk about because I'm confident that you guys know how to do that. All right, next thing, hash code. Hash code you will not know how to implement because there's some magic that's required behind the scenes. And in fact, I won't tell you how to do it right now. The reason is because it's complicated. And so later on in the course, when we get kind of to the third section, which is on searching, we're going to discuss a data structure / ADT called a hash table. So a hash table is basically a structure that requires you to know the hash codes of all these different objects, all the objects that are being stored within it, because it needs to basically pick a slot in an array to put them. But right now it's just a little bit too complicated for us. A hash code somehow needs to be this magic number that encodes the state of an object, right? It's basically a unique identifier for the object. And so it's like, well, if I have two objects that they have the same hash code, what that implies is that they are equal. That's why if you're in an IDE, typically IDEs complain if you implement equals, you're supposed to implement hash code as well, because those two things should agree, right? When they say that these things are equal, they should really be equal, right? I can't have a disagreement between a hash code and equals, because hash code again should be this unique identifier that tells me what this object is. All right. Last thing I have here, which is a new one, which we didn't talk about before, but which I add here because you should know about it and you should basically want to implement it sometimes. Well, you should know how to implement it, right? You should know how to implement everything. Clone. So this is what clone does, right? So clone is basically saying, make me a copy of an object. So normally, right, we've been drawing these diagrams and when we say, okay, so in the past, right, we've had code like this. We've said that we have things like, counter C1, and maybe we have another one, counter C2. And we go like, this one equals, new, this one equals, C1. We've had code like that, right? We did some traces and stuff like that, and we said, oh, hey, doing that basically produces the following image, where I have C2 and C1, and then basically what I have over here is I have, one counter, and they both know about it, right? Because we said objects were treated as reference types. And so when I do that equals symbol over here, well, they'll both end up being the same thing. Well, if I want, right, I can actually try to fix this. And the way I can fix this is with using clone. So instead of having this line here, C2 equals C1, what I have is the following. I can have, actually I should just erase part of this. I can do the following. If it's implemented, C1.clone. C1.clone is basically asking for me to make a copy of this object. So instead of just copying the reference, make a whole new object. And in that case, right, our picture will actually look different. It'll look like maybe what you expect, which is you have one thing over here and one thing over here. Okay. So in that case, right, basically clone calls new on the object to request a new one, and then it copies over one by one each of the instance variables, so they will be the same. And that's what we call basically a deep copy. So rather than doing a shallow copy, right, where we're just copying the address, we do a deep copy where it's like, well, build me a new object, go inside, manually transfer all the stuff that it contains, right? And that gives you an actual clone of the object. So yeah, that's the fourth one. That's another way basically to get around the issue with referential types, right? So referential type issues, right, can be addressed either with immutable types or by calling just clone all the time. Clone all the time, though, is a little bit problematic because of performance, though, right? Because every time you call clone, you're basically doing a new. New is a very expensive operation because it invokes a memory allocation, right? Memory allocations are one of the most expensive things that you can do in your code, okay? So calling clone too much is going to be, just a waste of time and performance, right? You don't want to have, a real-time loop in something, right? Like an operating system where you're calling clone all the time because you're just creating so many memory allocations, right? Every single cycle, it'll slow the system down. So generally not a good approach, although it is another way. All right, so that's kind of a quick run through for you guys. So hopefully now you have an idea basically about implementing these common methods, right? Main one is equals, toString you already know, right? Hash code we'll talk about later. Clone is nice, right? But not strictly necessary for us at this point.